We often think of the universe as this vast, expanding emptiness. But it's also a place of constant change, of matter clumping together, forming stars, galaxies, and everything we see. And scientists have just discovered something fascinating. The universe is actually a little messier than we thought. A new study, using data from powerful telescopes like the Atacama Cosmology Telescope and the Dark Energy Spectroscopic Instrument, has looked back in time. They've essentially layered snapshots of the universe, one from when it was just a baby, we're talking 380,000 years old, using something called the cosmic microwave background, and another from much later, showing how galaxies are distributed today. What they found was a small but intriguing discrepancy. The universe isn't quite as clumpy as our current models, based on Einstein's theory of gravity, predict it should be. Think of it like this. Imagine shaking a box full of sand. Over time, you'd expect the sand to settle into distinct clumps. But in the universe, those clumps of matter, which eventually form galaxies and galaxy clusters, are a little less defined, a little more spread out than expected. This messiness is measured by a value called sigma 8. A lower sigma 8 means less clumping. Now, how does this relate to something you might be more familiar with, noise? Well, in physics, noise often refers to random fluctuations or disorder within a system. Think of static on a radio, or the random jiggling of molecules in a gas. In a closed system, like a sealed box, the amount of disorder, or noise, tends to increase over time. This is related to a fundamental concept called entropy. Entropy is a measure of disorder, and the second law of thermodynamics states that entropy in a closed system always increases, or stays the same, it never decreases. Now, here's the crucial connection. While the universe isn't a perfectly closed box in the traditional sense, it is expanding, and the observable universe, the part we can see, can be considered a kind of closed system for our purposes. The observed lower clumpiness, the higher messiness, suggests a higher level of disorder than predicted. This increased disorder, this slightly higher noise in the distribution of matter, could be a reflection of fundamental physical processes we don't fully understand. It's like the universe's version of that static on the radio, a subtle hint that something is going on beneath the surface. One possibility is that dark energy, the mysterious force driving the universe's accelerated expansion, is playing a bigger role in shaping the distribution of matter than we previously thought. It might be subtly influencing how structures form, preventing them from clumping together as tightly as our models predict. This discrepancy, while small, is significant. It's not enough to throw out Einstein's gravity, but it is a clue. It's a whisper from the universe telling us that our understanding of its evolution, particularly the interplay between gravity, matter, and dark energy, might need some fine-tuning. Scientists will continue to refine these measurements with even more powerful telescopes, like the upcoming Simons Observatory. They are searching for more pieces of this cosmic puzzle, hoping to understand the true nature of this messiness, and what it reveals about the fundamental laws governing our universe. It's a reminder that even in the vastness of space, the smallest fluctuations, the tiniest bits of noise, can hold the key to unlocking the biggest mysteries.